what we are now going to be looking at is again types of instructions, not in terms of the addressing modes, not in terms of the number of operands, but we're going to look at like different systems of writing instructions. So for example, if you want to write a high level code, you have different languages. You have C, C++, Python, Java and so on. Similarly, for these assembly language instructions, there are different frameworks using which you can write them. So some of those frameworks are what we are going to be looking at now. The first is register transfer notation, which is something we already looked at in the first series of lectures, where you have specific notations like this arrow, capital letters to denote registers and so on. So register transfer notation essentially deals with the movement of data between registers. So this is one way of writing instructions in assembly level language. It has its own set of rules, its own set of syntax and so on, which we've already looked at. So we are going to be looking at 2-3 other types here in more detail. This is something we've already seen, so I'm not going to go into too much detail with this one right now. The idea is this is one of the ways of writing. Second one is assembly language notation. Again, all these types which you're going to be looking at, you saw register transfer, now you're looking at assembly language notation. Next we'll be looking at something called RISC and CISC. So the idea of all these different frameworks is the same. It is to be able to express a high level program as a bunch of instructions or micro operations which can be understood and implemented at the register level. And just like you have different programming languages which can help you write the same piece of code, so you have different notations which help you express the same set of instructions or micro operations. So that's the whole point of these. So first one we saw was RTN, the second is assembly language notation. So here again your R2, LOC, R2, R3, R4, these are registers, and instead of those arrow marks and braces which you had in the previous framework, here we have keywords. We have the word load, which is like a read operation. So you take the contents of LOC and you load the contents of LOC and put it into register R2. Add R4, R2, R3, you take the contents of R4 and R2 and then you put them in R3 and so on. So that is one set of instructions. Again, this set has its own syntax. Load, add and so on are keywords, and your operands must be separated by commas and so on. Moving on to the third type of instruction frameworks, we have two instruction sets called RISC and CISC. RISC stands for Reduced Instruction Set Computers and CISC stands for Complex Instruction Set Computers. So the idea here is, yesterday when I was explaining decoding of instructions, I took an example of a 16-bit number. I split it into 1 bit for the mode, 3 bits for the opcode and 12 bits for the memory address. But it is not possible to represent every instruction in 16 bits, right? So for example, if you take a 16-bit address and you allocate only 3 bits for the operation code, then you can have at most 8 unique operation codes, not more than that, because 2 power 3 is 8, and that will definitely not be sufficient to represent all the different operations in a computer, right? So that was a toy example just to make you understand how things work. In reality, instructions are much longer and they are not of fixed length, meaning every instruction is not equally long. Some are x bits long, some are 2x and so on. So that is where this idea of RISC and CISC comes. So these are two different frameworks. So in RISC, what happens is every instruction occupies exactly one word in memory. One word is generally equal to 8 bits, that is 1 byte. In some systems it is equal to 16 bits or 2 bytes. But in any case, one word is a unit of memory, and in the RISC architecture, every instruction is of equal length. Each of them is 1 word long. and all operands needed are already in the process registers. That obviously anything you want to execute, any instruction you want to execute, you will have to first bring the data to the register. So the idea here, the key idea with RISC or reduced instruction set computers is that sorry, every instruction is exactly one word long, and speaking in terms of computer memory, which is vast, which is gigabytes, terabytes and more, one word is a very small unit. So the instructions are small in size and hence they do not take a lot of time to execute, but it means a program will be broken down into a large number of sub instructions or micro ops. Now this is a key difference between RISC and CISC, so I would request you to pay attention here. So when you take RISC, I repeat, every instruction is exactly one word long, and one word is a fairly small amount of memory. So every individual instruction is short and hence requires less time to execute, but that means the overall program or code will be broken down into a large number of sub instructions. On the contrary, we have CISC, which is complex instruction set computers, where the instructions are arbitrarily long. They need not be exactly one word. They can be 2 words, 4 words, 8 words long. They can have any length, meaning your instruction size is longer, so the time taken to execute one instruction will be a little more, but your overall program will be broken down into fewer sub instructions. So now that was an overview of RISC and CISC. I will now give you a quick example. So let's go back to our the basic statement we've been using throughout this series of lectures. C is equal to A plus B. So this is one line of code I write. So if you take RISC like we saw, and if we try to break down that one line of code into sub instructions using the RISC framework, we will have a large number of simple small sub instructions. So for example, create location A, assign value to A, create location B, assign value to B, fetch A, fetch B, add A comma B, create location C, take that resultant sum, put it in C. So you as I just spelled out the sub instructions, you could have you would have noticed that there were at least 7-8 sub steps here. Each of them was very small. Creating a location it's a job of one clock cycle probably. So each of these instructions is going to take less time individually, but you had a large number of sub steps. Whereas if you go to CISC, and if you try to decode the same line of code, C equals A plus B, using CISC, we will have for example, take the given value and assign it to a memory location with the name A. Take the given value, assign it to the memory location with the name B. Sum up the values of A and B and assign it to a location called C. So here we finished it in 3 sub-steps, but each of those sub-steps is a little more complicated, hence the name complex instruction set, meaning the time taken to execute them will be a little more. So as you can see, there is a trade-off here. If the individual instructions are simple and less time consuming, there are more of them required to accomplish the same program. If the individual instructions are complex and more time consuming, you need fewer instructions to finish executing the program. So ultimately, the amount of time taken to accomplish your task or to execute your code is going to be more or less the same, irrespective of whether your system uses RISC or CISC. But depending on what hardware, what architecture is present in your system, it might be easier or harder to execute certain instructions. For example, if your hardware is made up of very basic components, then executing complex instructions might be a little difficult. So in that case, the system will be programmed to use RISC. So that is the whole idea of RISC and CISC. One is simpler but more instructions, the other is complex but fewer instructions.